Okay folks, just going to walk you through here some of the different kinds of stairs that you can often see inside a Revit project. So here we've got, this is a Honda Way dealership in Abbotsford. So one of the projects that I've worked on over the years. And so I'm just going to switch to a different 3D view here that shows the interior of this building. So just some of the furniture, and I'm going to focus on the stairs and railings. No. Okay, so here is a set of stairs which has an HSS tube on the side, and then concrete and steel treads. So of course there was here, if I just select it here, you can see the pans that the concrete was poured into, and then there was a curved steel riser that went up behind it, and this is just an HSS tube that's on the side of the stair. Now running alongside the HSS tube was this handrail, which is actually on the wrong side of the, I don't know what I did here, whether I flipped it. Nope. Something has gone bad here, because this is what it's supposed to look like here on the outside. So you've got these plates which sit around the outside of the HSS tube and hold the glass in place. So you had these big thick pieces of glass that had pre-drilled holes in them, and then they had these plates that were welded on to the structure in the background, and then stainless steel discs threaded on top to hold these glass plates in place as they would go down the HSS tube stringer. Now this is of course the fancy stairs. Elsewhere in the building we had some much more basic sorts of stairs. So these ones here are just a simple set of steel stairs with you know, C-channel stringers and steel pans, and again concrete poured in these. I'm just trying to figure out why everything's cut off. I must have a crop box on here. Oh, there we go. Okay, there's the rest of the stairs there. So you can see there's stair and a wall-mounted railing. So just an exit stair at the back, feature stair at the front, and then another exit stair in the back with wall-mounted handrails. And we're going to talk about how to make these in a few minutes. This is exactly the sort of thing that you folks will be making tonight. Okay, so just going to save this and then we will carry on. So I'm just going to open up a stair inside the architectural template now. So looking at the stair tool here on the architecture tab. Now when you start up the stair tool, you're going to have the three different kinds of stairs that Revit creates. And so when you look in the properties palette, look for the three gray headings: assembled, cast in place, precast. So cast in place and precast are your concrete stairs, and assembled stairs is wood frame or steel. So even if your steel stair does have some concrete in it, you would still start with the assembled stair style, because assembled stairs can have stringers and then your treads. The monolithic and precast stairs here, the cast in place and precast stairs, do not have stringers. It's just concrete. So a much more simplified construction for those two different stair types. Now, component versus sketch-based stairs. In recent versions of Revit, sketch-based stairs have been heavily deprecated. They're gone. Used to be a thing where we had to use the sketch-based stair tools. We'll show how you can still get to them, but for now we're just going to dig into these component stairs. So again, architecture tab, stair tool, and I'm going to use the assembled stair and just draw a straight run of stairs from level 1 to level 2 and finish. Now maybe I'll just undo a step here. with these assembled stairs, the advantage is that as you're drawing them, if you were to look in 3D, you actually do get this 3D preview of the stair. I don't know if you folks caught that, but in 3D now, Revit shows the levels in 3D as you orbit the model. See those 3D levels in the background? You can turn them off. I actually find them distracting, but some people might think that's kind of cool. It would actually be in the background behind your model, so it wouldn't obscure anything, so you'd see these levels emanating out from the side of your building. So to get from level 1 to level 2, that's not all the stairs that are needed, obviously. I've only drawn 10 risers, so I'd have to use the run tool and keep going. So as I'm drawing these stairs, I'm getting a 3D preview even before I finish. Now, these assembled stairs have 3 general parts. There's the run in between the supports, and you've got your supports around the outside, which we're going to talk about. They come in 2 different flavors. So these supports are either closed, like what we're seeing here, or open. So an open support is one where it's notched, so you can see the tread from the side of the stair. And then finally, landings. So this landing object right here. So you have runs, landings, and supports. So that's looking at the bottom of page 1. Now, let's flip over to page, what do I want to do here? I think I'm going to go to page 4 and just talk about defining supports. I'm going to jump around a little bit here. So let's talk about the supports first of all. Now the supports are defined in your assembled stairs type properties. So when you go into edit type here, so these are the type properties for your stair, and you can see here under supports you've got your right support and your left support, and you can toggle between a closed stair, or sorry, a closed support or an open support. So the open support, that means that you can see the treads from the side. So there you go. So that means your supports are notched. So Revit calls that, in its internal jargon, it calls it a carriage. Now we would call it a stringer. So what Revit calls a stringer means you cannot see the treads from the side. So that's what Revit is calling a stringer. I find that terminology a little bit unfortunate, because in the construction industry we would not differentiate between a notched stringer and an unnotched stringer in this manner, but that's how Revit defines this stuff. Now, Revit lists all of these supports in the project browser under railings. No, not under railings, under stairs, for crying out loud. Stairs, there we go. So you've got your stringer folder and your carriage folder. So assembled stairs, the supports for them, all the different kinds of carriages and supports and stringer supports would be listed in those 2 folders. Now, I'm going to go back to the stair here for a moment and go to the type properties. When you switch modes between stringer mode or carriage mode, then Revit lists to you all the defined stringers or carriages in the project. So here, if I expand carriage and if I expand stringer, there's only one carriage type and only one stringer type defined so far. Now, you can define more. So I'm going to go to the stringer section here, and I'm just going to look at the type properties here just by right-clicking on stringer 2-inch. So, with your stringers, the default profile is, that means rectangular. So this is saying a stringer 2-inch width. Now, that's not a thing you can get at the lumber yard, so I'm going to duplicate this, And I'm going to call it a 2x12. So now I've got a 2x12 stringer, and I'm going to give it the dimensions such as you would find for it at Home Depot. So that's 11.25 inches by 1.5 inches. So now I've got a true 2x12 dimension. Now, structural depth on run. That means the minimum amount of meat that's not cut at the back of the stringer as it's notched for your treads. So it means minimum amount of 2.5 inches at the back. I think the building code in part 9 says 70 millimeters, which is a little bit more than 2.5 inches. So what? I could make it 3 inches and make sure that we're absolutely golden on the building code front. So this means now that it will keep at least 3 inches of stringer depth unnotched at the back. So now I can hit OK. So I've defined this new kind of stringer, but now I need to go back to my stair and tell my stair to use that new 2x12 stringer. So if I just click off here so I don't have anything selected, I'm inside my stair sketch, and now I can go to my type properties. Instead of using this 2-inch stringer, I hit the little ellipsis button here. It actually pops up this extra dialog here. So I can switch now to the 2x12. And I'll do that on both sides. So now it's a 2x12, dimensional 2x12 piece of lumber on either side. And if I were to look at it in wireframe, so that's the 3 inches right there. That's called the structural depth on run. And I think it is dimensioned in our notes somewhere so you folks know what that is. So that is a stringer. Now, again, in your stairs type properties, you've got your right support and your left support. And if you want, you can define a middle support. Now, your middle support only allows the carriage because the carriage is notched. There's no way that you could have a piece of the stringer poking up above your steps and getting in the way. So Revit only allows these carriages to be done. So when I hit OK now, there's the support that's running down the middle of the stairs. So if you're doing like an outside set of stairs off your deck, you know, if those stairs are more than 3 feet wide, you'd probably have to put another stringer down the middle of the steps to keep them from bowing when someone is standing on them. So that's the purpose for having those middle supports. So again, you can switch modes between stringers and carriages. So again, it's going to list all the carriages that we've defined so far, so it's only that one there. So I could go back to my carriages now, go to the type properties of this. Same thing, I could make a duplicate of this or rename it in this case. I'll make it 2x12. Oh, right. So duplicate. The names of my carriages can't be the same as the name as any of my stringers. Okay, so now in my stairs properties here, there. So now you can see I can see the treads from the side. Okay, runs. Now, just like we've got a separate subfolder under the stairs directory, or the stairs folder in the project browser for your carriages and your stringers, there's also a folder for the non-monolithic run. So your non-monolithic run, that is the different kinds of your run construction, so that's the stuff in between the supports. So you can define this thing right here. This is the run. So you can see here, non-monolithic run, 2-inch tread, 1-inch nosing, blah, blah, blah. Now again, this isn't a real construction. So I'm going to right click on this thing and I'm going to duplicate it. So again, I'm still inside my stair sketch. I haven't even finished it, but I could just as well. So if I were to finish it now, see, it adds the railings on the side. So I can either make these changes to carriages and stringers while you're editing the stair, or even when you're not editing the stair. The advantage of editing the stuff while you're editing the stair is that you can see the changes right away. So here I'm going to right click while I'm editing the stair, go to type properties, and I'm going to rename this 2 by tread, and I'll call this 1/2-inch riser. And I will keep the 1-inch nosing, but we're going to change it in a second. Now, with your run, you cannot define the depth of the tread within this run object. The stair itself defines the length of the tread, not the run. All the run does is define the thickness of the tread and the thickness of the nosing, and also the depth of the nosing. And actually, this is a really good point here. When we talk about what Revit calls tread depth, so we'll see this in a second when we go back to the type properties of the stair. But what Revit calls tread depth is actually the run. Now, Revit does include a nosing but this is how Revit does it. And again, this Revit's jargon does not correlate with our building code definitions of typical run. So what Revit calls the tread depth is what the code calls the run. Now, they are both in agreement with regards to the nosing. And that's the part of the tread that protrudes in front of the riser. So we do have correlation there. But normally what we would call the tread depth is this. But Revit doesn't even have a part of it that can handle that. Let me just color code this. So I'll do Revit stuff in blue here. Code stuff is in red. So in red here, I'm talking about the tread depth, but Revit ignores the nosing when it talks about its own tread depth. It just adds the nosing to the tread depth. So to make an equation here. So the Revit tread depth and nosing equals the real world tread depth. So just be aware of that when you're setting up your running your nosing in Revit. Now this is a wood frame stair. So there's no need for anything except a real basic rectangular profile to the front of the tread. So in your run properties, you define the thickness of the tread. So 2 inches, of course, is imaginary. So I need to make that 1.5 inches. Nosing length of 1 inch is cool. We can roll with that. But the nosing profile. So here it's got a stair, sort of a little angled nosing profile, which on a wood frame stair is senseless. So if we switch here, there's one called default, which simply makes a rectangular front to the nosing, same thickness as the tread. So now you got a 1 inch nosing, 1.5 inch thick tread, riser thickness, I said it's going to be 1/2 inch for 1/2 inch plywood. And that's it, we're good to go. So as soon as we hit OK here, now you can see our stairs have changed, so we have a rectangular front on a wood frame stair. So that is the run. So the non-monolithic run here. So if you want to make some wood frame stairs and you've got some steel stairs on the same project, you just, type properties and duplicate it, and then you could say steel pan run, and in here you could have maybe a 2 inch thick steel pan with concrete inside it. So you would put your tread in here, change your tread material to concrete. So if you had a steel pan with concrete, so you want to have exposed concrete treads that you can see, that all can be done here. And then if you want to have a different nosing profile, so it's not just a rectangular front to the stair, you got a little bit of a shape to it, then you can add that nosing profile in here. So just remember, if you make a new run type in the browser, you have to have a stair type that uses it. So right now I've made this new non-monolithic run type here for steel stairs. But right now in my railing types, I don't even have that yet. So I've got this assembled stair, which is 7 inch riser with 11 inch tread, but it's only defined as wood. So really what I would do here is I'll rename this. And it's using all of my wood frame stuff here, right? So wood frame run, wood frame support. Now, if I'm going to make a steel stair, I would duplicate it and call it a steel stair. And then I would use a run style, steel based, and then pick supports to create that steel stair. So we will do that in a few moments. Okay. Now, let's just, for just a moment here, go back to page 2, just at the top there. So in terms of what you see in the stairs folder as you're working with your stairs, again, it's this real sort of dog's breakfast of organization for all the stuff that's being used for your stair definitions. So first of all, you have the folders in which all of the different stair types are defined. So here we have our assembled stair list. That's your wood and steel stair types, right? I won't write it all up. Let's keep it green here. So that's your different kinds of stair types. Then you've got your precast stair here, and then you have your cast in place stair. So these are the three different kinds of component stairs that you can build in Revit. And Revit just kind of lists them all in the same hierarchy as soon as you open up stairs. So already the brains are beginning to hurt because there's no differentiation in this folder. Then you have these folders that we've been talking about. You've got your stringer folder for your supports. You've got your carriage folder, again for your supports. And so the stringers and the carriages, they are in support of these assembled stairs, right? So that's what's in those directories. Same for non-monolithic landing and non-monolithic run. So everything here, again, is designed to help define those assembled stairs. Then your monolithic landing and run. These are used to help define the cast in place stair and the precast stair. And just finally, to put the dagger in the brain of insanity, down here in this stair folder, it lists the old school Revit sketch-based stairs for which there's no tool in the interface to access them at all. I see dead. What I see is actually dead tools in Revit that are still listing in the project browser that you actually can't get access to in Revit. And what I mean by that is, anybody here use Revit 2017 or newer? Or older? 2017, 2016, 2015? Yeah, okay. So we're talking about, so these old, Tales from the Crypt stairs here that you see, these are called sketch-based stairs. And when we use the stair tool now, look, there's just a stair. Well, that means you're using these component stairs, which are either assembled, precast, or cast in place. So if you want to use those sketch-based stairs, I think you can just drag and drop them, one of them into the view, like this. Oh, no, they're not even sketch-based. You know what? I don't even know what's going on anymore. That's really weird, because the old sketch-based stairs, when you were working on it, you wouldn't see a 3D stair. You'd see green lines on the side and black lines for the risers. So that's the old school Revit stair. I don't even know what this folder's for anymore. Because, yeah, so anyway, you can just ignore that folder. I'll have to dig into that a little bit because this is the first time I've dug into or used the 2019 stair set. Finally, the stair cut marks down here, that's just some graphical stuff. So going back to, this directory and what it's all for, that's why I listed all this stuff in the notes so you'd understand the disorganization, as I call it. It's not stair, it's not project browser organization. To me, it's project browser disorganization, because these green ones here are actually the most important, and these other parts of stairs are listed in the same hierarchy, which to me is like a user interface fail of the highest order. It doesn't help you folks understand what's going on. Now, let's try and clean things up a little bit here. When you're working with these stair tools, I'm going to go back into the plan view here. Now, hopefully you should all understand this by now. Let's go to the bottom of page 3. When you're working with stairs, so during the stair editing section of the work, so while you're in sketch mode and you can see the green check mark to finish your work, when you're putting these stairs into your design, Revit counts all the risers as you're going up, and you want to make sure that your desired number of risers, 18, is equal to the actual number of risers. What Revit does is it tries to give you the minimum number of risers required until you hit the maximum riser height, which you define with your stairs. So when you're in your stairs type properties, not only do you define the run and you define your supports, you also define your maximum riser height and your minimum tread depth. Now again, remember when Revit says minimum tread depth, that means the run. So remember that in Revit, minimum tread depth is actually the run, so you can add your nosing to that to get your actual tread depth. So most commercial buildings, we're going to work with 180 millimeter maximum, 180 mm. So a little bit more than 7 inches. So based on this 7 and 11 128ths of an inch, Revit will give us the minimum number of risers without exceeding that number. So you can always see if you can go a little bit lower than that, and I can, now I can. So I could actually use 17 risers because of that change I made, just going from 7 inches to 7 and 11 128ths. One less riser needed. So Revit now says 17 plus 1. I can get rid of one. So let's just talk about the handles. When you're clicking on each run, you've got a dot handle and a triangle handle. The dot handle will change the number of risers in the stairs. Now, if it's a straight run stair, you want to find the top of the stairs where the rising number is highest and use the dot handle to change the number of stairs or number of risers in the stair overall. You can only change the number of risers in your stairs by using the dot at the top of the stair. For whatever reason you try and change it at the bottom, weird stuff happens. Let me show you. I want to get rid of one riser, so I have to use a dot handle for it. So I'm going to go down to the bottom of the stair, grab the dot handle, and drag it up one riser. So we go from 0 to riser number 2, which means it's like everybody's sitting up for a Captain Morgan commercial. There's no riser 1. You go 0 to 2. So dragging that dot handle at the bottom of the stairs doesn't work. So I leave that one, go to the top of the stair, grab the dot handle and pull it back. So now we've got the right number of total risers. Now if we want to adjust the number of risers in each flight, triangle handle. There we go. Now Revit won't just allow you to drop this triangle anywhere. It goes by a discrete increment of your tread depth. So whatever you set as your minimum tread depth for the stair in your type properties, oh, I have type property. Yeah, I've got the run selected, that's why. So I need to click off. And now, yeah, there's my type properties. Minimum tread depth. So it's going to adjust that in increments of 11 inches. Now the triangle handle, you can use that on the upper flight or the lower flight does the same thing. So if I drag the handle in one direction on the upper flight, I'm going to drag it on the lower flight, no problem. It doesn't mess up your risers. So again, adding or removing risers from a flight, triangle handle. Adding or removing risers for the entire stair, pick the upper end of the stair, drag the dot handle to suit. And then changing the width of your stair. When you pick each flight, just pick it, change the dimension, then pick the landing, change its dimension. Before you draw the stair, you have a chance to set that up. So here when you're using the run tool, before you start drawing the run, if you want to make a 4-foot stair, wide, there you go. So now as you start drawing that stair, it's going to be 4 feet wide, but you can adjust it later. And then when you're working with the stair, you can select each flight, move it around. You can put dimensions between the flights, so you can adjust the exact spacing between those two flights. So here I can use the dimension command. So if I want them just to be 6 inches apart, pick either one of your flights, it doesn't matter which one. Put in 6 inches into your, and there you go. So when you're finished, of course that dimension disappears. Revit's probably grousing because it's having to do a harsh corner with that railing, so it's just saying that it can't keep the top rail continuous.
So, the assembled stairs with the steel, when you enter the stair width, is the dimension from the stringer like outside or inside?
To the width of the tread.
Okay. So then in reality, you have to add stringers. Say if you have a staircase, right?
Well, your tread depth, your tread width.
No, the
Oh,
stair
I see what you're saying. No, I think it measures it actually to the outside of the treads. So.
Not including the stringer.
Yeah, I think it's to the outside of the stringer. Yep. So it's net of the stringers, and that's a good point. So when you specify your stair width, Revit includes the stringers in that number. So if you want to make sure that you've got a minimum 4 foot of width of the treads themselves, then you have to consider the width of the stringers as well and add that to the width of the stair, either when you're drawing it or later. I can come back later, edit the stair just by double clicking on it. There we go. And then click on my stairs here, and I'd have to make them 4'3". So there you can see 4'3". And then I'd have to go back and do the same to my landing. So there's the 4'0". Again, just put in 4'3", 4 space 3. And now the landing is where it needs to be for width as well. Okay. Now there's other stuff here about adding railings to a stair and all that other stuff. I'm just going to skip that because I want to get into railings soon. But we are going to talk about creating a custom support to do a steel stair. Let's go skip on to 5. Let's go on to page 6. Now, one of the reasons that component stairs were developed was because one of the things that we Revit users have wanted for a long time was an ability to have Revit number the treads in a stair. So we could, on our plans, and for the plan checker, they could quickly see that the stair is compliant. On the Annotate tab, they have the tread number tool, which numbers the runs. Okay, so the tread number tool numbers the run. Doesn't actually number the treads unless you ask it to. It numbers the runs. Not the runs, the risers. So here when you pick the tread number tool, in the properties palette, you can see right away it's tagging the riser. So why didn't they call it the riser number tool? Don't know. So here with the tread number tool, you can number the risers, put your cursor on either the third point or the midpoint or the other third point of the stair, and it will number all of your risers for you. I hope you like Arial as a font, because you cannot change the font. Okay, it's not Comic Sans, but it would be nice if we could change the font. So you're stuck with Arial as the font. So then you can choose the justification. So you want it centered on the riser. I don't know why Revit doesn't do this, but that's how your stair numbering works. All right. So finally here, an exercise for you folks to dig into. So here you're going to make a steel stair and change the supports so that you can make a steel stair with the steel supports at the side. So if you guys want to just start on page 6 there, give that a go.